Now we'll come to problem number 3. In this problem, it has been said that there is a point charge, 5 nanocoulombs. It is located at -340, while there is a line y is equal to 1, z is equal to 1, carries a uniform charge of 2 nanocoulomb per meter. So he is asking three things. This is question number 1. If V is equal to 0 volts at this point, then find V at this point. Second thing is, if V is equal to 100 at this point, he wants V at C. And finally, he wants, if V is equal to -5 at O, find VBC. So this is what he wants actually. So let's try to determine at least one in this video lecture. Now, if you see the question, there is a point charge and also there is a line charge, which means that if we consider an XYZ system, there is a point charge at -3, 4, 0, which means that there is some point P which is at -3, 4, 0. There is a point charge, a small q, let us suppose. And also there is y is equal to 1, z is equal to 1, carries a uniform charge of 2 nanocoulomb per meter, which means that there is a line here. There is a line charge also. See, two charges are there, and the line charge value is lambda is equal to 2 nanocoulomb per meter. So there is a line charge and also there is a point charge. And what he wants to determine is potential at some point. Let us suppose this is the point O, origin. So two charges will be exerting potential on this point. So you need to determine potentials due to two charges and adding them using superposition theorem. We have done for unit line charge and we have done for point charge, but now we are going to do it for two different types of charge distributions and then adding them using superposition theorem. Okay. And for point charge we have already done here, and for line charge also we have already done. But for the sake of understanding, for sake of easiness in our problems, what we will do is nothing but Q is a line, Q is a point charge which is located at P -3, 4, 0, whereas lambda is a charge density, line charge density. It is not having a single point, it is having a continuous line, right? So where the x coordinate is unknown, it is x, whereas y coordinate is fixed at 1, z coordinate is fixed at 1. So these are the locations of these two charges. One is point charge, the other one is a line charge. This x will be varying all the time. So now you are supposed to determine a potential due to these two charges. Okay. Now, moving ahead. Now we will start with this first one. If V is equal to 0 volts, we'll start for this one. But before going any further, now we do have one first charge is point charge of, what is its value? 5 nanocoulomb, and its location is -3, 4, 0. Second thing is line charge. It is having 2 nanocoulomb per meter, and its location is y is 1, z is 1, but x value it will be varying. Okay, so because of these two charges, we will try to determine the potential first of all. Then we will try to solve these problems. Okay, so let me start with this one, assuming that the potential created by this one is V1, potential created by this one is V2. Okay, and the field which is created by this one is E1, field created by this one is E2. Okay, now because of a point charge, you know what is the value of potential which is created by the point charge. We have already done in the earlier classes. What is V1? If you want, you can do it as minus integral E dot dl. But since we have already done it, we know it's what? It is Q by 4 pi epsilon naught epsilon r. If you want, you can directly merge them as epsilon r. So V1 is equal to Q by 4 pi epsilon r. Normally there will be a constant. because we are integrating it, there will be a constant, but most of the times we ignore that constant. But here let us keep that constant as C1. Okay, so this is the expression. Now in this one, what is the value of Q? Q value is the point charge. Here Q is point charge, and R is distance between point charge and point of consideration, isn't it? So this is how we will determine V1. Now coming to V2, which is due to this line charge. We have already done this type of line charges. What he has said as 2. So its value is 2 pi epsilon naught ln. Here I'll take it as ln r, or else I'll take it as ln h or ln a, where a is a perpendicular distance between the line charge and the point of consideration. Okay, because to not get confused with this r, I'll take it as ln a, where lambda is the line charge and a is perpendicular distance, or what we call it as the shortest distance, right? Perpendicular or shortest distance from line charge to point of consideration. Okay, here also there will be a constant because we will be integrating all the time. Last class we have ignored that one, but let us consider this one. So now what is the total potential applying superposition theorem? Here I think there will be a minus here. Okay, here there will be a minus. So it is Q by 4 pi epsilon r. This is due to the point charge, where r is the distance between the point charge and the point of consideration. And for this one it is minus lambda by 2 pi epsilon into ln a, where a is the shortest distance between the line charge and the point of consideration. Okay, if it is air, you can directly take it as epsilon naught, but if it is a medium, you are supposed to take it as epsilon naught into epsilon r. Okay, plus some constant C1, C2, both are constants. So I will take a normal constant C. This is voltage due to the combination of both line charge and also point charge. Now we will try to determine these things first of all. Okay, now let's get back to this one. So let me write this equation once again. V is equal to Q by 4 pi epsilon into r minus lambda by 2 pi epsilon into ln a plus some constant, right? So this is the expression. Now question number 1. V is equal to 0 volts at this point. So at O 0, 0, 0. At this point, now what is the value of R? R is nothing but what is R? Distance between point charge and point of concentration, right? So what is this point charge? Point charge is at -3, 4, 0. What is your point of consideration? 0, 0. So what is R at origin? I'll write it as RO. So its value is square root of -3 minus 0 whole square plus 4 minus 0 whole square plus 0 minus 0 whole square, right? So its value is square root of 9 plus 16. It is square root of 25. Its value is 5. This is R naught. Similarly, because we need to determine at A also, I'll write it as A also. What is the value of A? phi 0 0. So what I'll be taking? Phi minus 0 square plus 0 minus 0 square plus, sorry, it is 5 minus 3, right? This is the point charge location. So 5 minus of minus 3, 5 minus of minus 3, and this is 0 minus 4, and this is 1 minus 0 whole square. So it is square root of 8 square is 64 plus 16 plus 1. So its value is square root of 81. Its value is 9. So R naught is 5 or A is 9. Similarly, let us consider this particular A value. Okay. So this is at A 5 comma 0 comma 1. Now we will consider this A values. A value is distance, shortest distance between line charge and point of consideration. My point of consideration can be origin at O or it can be A at 501. So how to determine the shortest distance? Line charge is already at x comma 1 comma 1. Right. Now my point of consideration, O is at this way and A is at 5 comma 0 comma 1. Right. So what is the shortest distance between these points? If you consider the shortest distance between these, so I have to consider A at origin. It is a distance between this point and this point, right? Say x value I don't know. If I don't know x value, I can directly take it as 0 itself. Because, so that's why I'll consider between 0, 1, 1 and 0, comma 0, comma 0. Why I'm considering this one is, I want the shortest distance. So to minimize the shortest distance, what I should do? I'll make this difference as 0. That is the easiest way what I can do. So what is the distance between these 2 points? 0 square plus 1 square plus 1 square, it is root 2. And for A, again what I will do is to get the shortest distance, this at least this component should be made 0. So for that one, what I will be taking here? 5 comma 1 comma 1 and 5 comma 0 comma 1. So this will make this component 0. So I will get the shortest distance. That's why I am considering. So this will become 0 again. This is 1 square plus 0 square. So what is the distance? 1. So now for determining the potential at origin, this value is R naught is 5 and A naught is root 2. And at A point, this value is, where is this one? Yeah, 9, right? 9 and this is 1. So now with the help of this one, we are supposed to determine this particular problem. Okay. How to, yeah, let me write it again. V is equal to Q by 4 pi epsilon naught R minus lambda 2 pi epsilon, because I am considering directly epsilon is equal to epsilon naught. I am considering air medium. Okay. Epsilon naught into ln A, some constant. So at origin, R is equal to 5 and A is equal to root 2. At A point, which is 5, 0, 1, R was 9 and A is equal to 1. So now I will determine the potential at 0. Its value is Q. Q value is already, you know. What is Q value? 5 nanocoulombs, and lambda value also, you know. Its value is 2 nanocoulomb per meter. And you know this epsilon naught value, 8.85 into 10 to the power of minus 12. So what you will be getting here? So what I can do is nothing but 1 by 4 pi epsilon naught. I will directly write it as 9 into 10 to the power of 9. Or if I want 1 by 2 pi epsilon naught, I will write it as 18 into 10 to the power of 9. Okay. This is what I can do. So I am applying this one here. V naught, first of all, 1 by 4 pi epsilon naught. This is 9 into 10 to the power of 9. into Q value, I know what is Q value, 5 into 10 to the power of minus 9 by R is 5 minus lambda is 2 nanocoulomb, right? It is 2 into 10 to the power of minus 9. This 2 pi has 18 into 10 to the power of 9, right? By, into ln of A at origin is root 2 plus C. See what is the value here? 5 will go, 10 to the power of 9, 10 to the power of 9 will go. This is 9. This is 2, 18 to the 36. 36 into ln of root 2. ln of root 2. Let me do the problem. 1 minute. So this is 2 into, this is 2 into 30, 18, 36. 36 into ln root 2 I have done immediately in the calc. Its value is 0.346 into this, both will get cancelled, right? This is 36, 18 to the 36. So 0.346 into 36. So what are you getting? 12.456. 12.456 plus C volts. So what is the answer here? It is minus 3.456 plus C volts. This is voltage at the origin. Now if you want to determine voltage at it is already been given that V0 is equal to 0, right? So since V0 is equal to 0, it is already given, right? At origin, voltage is 0. So what I can write? I can write it as 0 is equal to minus 3.456 plus C. So what is the value of C? C value is 3.456. C value is 3.456. So I can directly replace here. C value, what is the C value? 3.456. Isn't it? Now, what I will do is, I'll determine the voltage at A. Voltage at point A. So how to determine the voltage at point A? Again, I'll go with the same equation. It is 9 into 10 to the power of 9. 1 by 4 pi epsilon. Into Q value is the same. It is 5 into 10 to the power of minus 9. By R value. R at here is, it is 9. Right? Minus 2 into 10 to the power of minus 9. Into 18 into 10 to the power of 9. This time it is ln1, right? ln1 plus C value. What is the C value? It is 3.456 because I have obtained in the last one. So if I substitute these things, here 10 to the power of 9, 10 to the power of minus 9 they will go, 9 and 9 will go, its value is 5, minus here also they will go, 36 into ln1, that I will do it now. Ln of 1, it is 0. So it is 0 plus 3.456. So its value is voltage at A. So similarly, you are supposed to determine the voltages at different points. Now see the question number B. What the question number B states? If V is equal to 100 volts at B 1, 2, 1. Similarly, what I have done now, I have used this equation. I have determined the C, and again I have utilized that one to determine this value. Now what you are supposed to do? You are supposed to use this one to determine the value of C. C value will vary, right, for different conditions. So again you are supposed to do it, and using that value again you are supposed to determine V at C. And finally, B and C points are fixed. So with the help of this one you determine C value, and using that, you know, B and C, determine VB and VC, and then you determine what is the difference between VB and VC. So this is the way how we solve the problems on potential. Thank you, and we will meet in the next class.